In this lesson, we will talk about maps in Java. The map data structure, much like the set data structure that we talked about in other lessons, stores entries, a collection of entries. Except that a map stores an entry which is made up of a key and value pair. The key part is used to facilitate fast searches, fast retrieval, deletion, and updating of the pair. The value part is the actual data that you operate on, right? So if you recall, in lists, we used indexes to access elements of the list, and these indexes were integers. Now, in maps, we use the keys to access things, and keys are the indexes. But keys can really be any object. They don't have to be limited to integers, right? Now, maps also cannot have duplicate key. Each key must be unique, and one key maps to one value. So visually, it can be thought to look like this. A map is a collection of key value pairs. There is an entry, and each entry is made up of a key and a corresponding data element, right? So in this example, you have possibly social security numbers, which are the keys, and the name is the actual value, right? So the map interface is also a generic. Now, we are not used to seeing generics with multiple types, generic types, but here you have a generic with two types, right? And the map interface defines common features of the map, right? It maintains methods for querying maps and updating them, and so on, right? So if we look at the portion of the UML that deals with maps, it is like this, and we have the same pattern. We have certain interfaces, and we have abstract classes that implement part of the interface, and then you have concrete classes that complete the implementation. Now, map provides a fairly detailed collection of methods, and these include clear to remove all entries of a map, put with a key and value to create another entry in the map. Now, if it finds an existing entry with that key, it'll just update its value to that, right? And put, which takes another map, puts all the entries from this map into the source map, right? Remove removes an entry that matches that key, right? There are query methods that to check whether the map contains a key, map contains a value, if the map is empty, and what the size of the map is, right? Additionally, you have the following methods. You have key sets that returns a collection containing all the keys of the map. There is values, which returns a collection that has all the values in the map. Entry set is an interesting one. It returns a set of entries of type map.entry. Now, map.entry is it's what's called an inner interface of the map, right? That supports certain operations. It's an interface that is internal to the definition of the map, right? Abstract map is a class that implements all the methods above except for entry set, right? And that's implemented by the actual concrete classes, right? The three concrete classes that we have for maps are HashMap, LinkedHashMap, and TreeMap. Let's go and look at where they show up. So you have HashMap here, you have TreeHashMap here, right? Which you can tell they implement additional interfaces, and LinkedHashMap here, which extends HashMap. So let's take a look at what each of them do. Now, HashMap extends abstract HashMap to implement basic unordered HashMap, right? Like sets, there's a constructor that takes initial capacity and load factor. If you recall, capacity is how many buckets it has, and load factor represents like what portion of the buckets have to be filled up before we increase the size and double the size of the hash map. Okay, LinkedHashMap extends HashMap, the previous one, to support ordering of entries in the map, right? So LinkedHashMap, things can be maintained in insertion order, like as you inserted them, or they can be maintained in access order, which is when you touch that element first, right? And in the constructor, as we'll see in a bit, you can specify which one of these you want to use. If you say nothing, it's maintained in insertion order, and if you provide an additional argument, it will maintain it in access order, right? Then there's TreeMap, which is used to maintain the entries in a sorted order. And again, when you talk about sorted, keys have to be sorted using a comparable interface, which is by default, or provide a comparator. So if you're not confused by that, do look at those lessons again. Okay, so best way to learn this is to look at an example. And in this example, we create all three of those type. So we start here by creating a hash map, right? The hash map, the key is a string and the value is an integer, right? And here we just have a bunch of names and possible ages for these people, right? And that's what we are maintaining. Now, if you print it out, you'll notice that, it's displayed with curly braces and with, these pairs. But you will notice that the order in which they were put in the map doesn't represent how they are represented here, right? So it's unordered. Now let's look at the tree map, which does keep it in an order. So here we create a tree map giving the original hash map in the copy constructor. And then you print that and you'll notice that it is in alphanumeric increasing order, right, using the key. Lastly, we have LinkedHashMap, which can maintain it either in insertion order or access order. And here we're using a constructor that allows us to specify true for access order. And this is the capacity, and this is the load factor here. So we have we put a bunch of entries in there in this particular order, and cook being the last thing that is put there, right? So it'll be put in that order. Except then we go ahead and we access the entry for Lewis, and we print it. So now we've touched Lewis here, that entry. So when you print it, you'll notice that Lewis is at the end, right? Because it was accessed last, right? So let's try this out. We're going to just copy this and try it out in IntelliJ. So we'll paste the same code here and run it, and you will see, it is exactly what it shows in the comments. Feel free to play around with that code and to see what happens. Now, for example, we could try something here, and we could make this false, right? In which case it'll be kept in insertion order, so we'll no longer have Lewis at the end. So let's try that out. And you see now cook is the last thing that it's maintained in insertion order, even though we have touched the entry for Lewis. All right. So now we should talk about when we use each of these things, right? So if you just if you don't really care about maintaining an order, you would use HashMap. If you want to maintain insertion or access order, you would use LinkedHashMap. And if you are interested in sorted maps in the sorted order of keys, then you would use a TreeMap. So this has been a lesson on maps, using maps in Java. Thank you.